All right, we're going to take a look at what formulas we can use to expand problems like this. So this is a binomial. You have two numbers here. The 2x represents one number, and the 3 represents the other. And this is to the fifth power. Normally, we would have to take a number of steps with box methods to multiply all of the pieces out. But there are formulas that we're going to save us a little bit of time. So I'm going to call the 2x, that's going to be the a, and the 3, that's going to be b. And we're just going to talk about the formulas with a's and b's so that we can use them in a broader variety of circumstances. So starting with the a plus b to the 0th power, anything to the 0 power is 1. And that formula is not very interesting. If we did to the first power, that would be 1a and 1b. Again, not very interesting because it doesn't require a box method in the first place. This box method, though, if you wanted to square this, it would be 1a plus 2ab plus 1b. Oh, and these are squared. Now, the reason why that works is because if you multiply a plus b times another a plus b, we get a squared, we get b squared. So there's one of those. And then in these other corners here, this is a times b, and this is also a times b. So therefore, there's two a times b's. Now, anytime we use something to the second power, that's the formula. The next level here, a plus b to the third, is 1a to the third, 3a squared b to the first. I'll start writing the exponents here. Plus 3a to the first b squared plus 1b cubed. And at this point, you should start seeing a pattern developing. There's a pattern for these coefficients. So these numbers in front, those are called coefficients. And these specific ones are called binomial coefficients because that's what's happening here. We have a binomial. A and B are the two nomials or the two numbers. And these values are predictable. So you have a pattern for the orange numbers. And if you were to ignore everything else and just talk about the pattern, 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, these numbers, if we wanted to get the next row, we're going to take, notice how they're sort of staggered in between the numbers above it. It always starts with a 1. And if I wanted to get the next number, I add the two previous ones on top of it. So this would be a 4. And the next coefficient is going to be a 6. And then a 4 and a 1. And it's always symmetrical, so you can use that to your advantage. Meaning that a plus b to the 4th power would be 1a to the 4th. Then the next coefficient is 4. And now notice what's happening with the a's. The a's are counting down from the maximum exponent. So the next a is going to be a to the 3rd power. And the b's are counting up from 0. So there weren't any b's in this term. The next term, it will be b to the 1st. And then 6 a's counting down while b counts up in exponent. And 4 a's counting down while b counts up. And then we end with 1b to the 4th.
How do you do that?
It's math. All right, the next row is going to be those coefficients. And so if we wanted to expand a plus b to the 5th, that would be 1a to the 5th, 5. A is counting down. So we went a to the 5th. Now this will be a to the 4th. B counts up. And I'm getting a little squeezed here for space. B counts up. This one's going to be this similar. and so on. So these coefficients, there is a formula for getting these in another way, but that's a separate video. And in the next video, we're going to use these formulas. So what you're looking at here is I guess technically it's 6 different formulas. And we're going to just use this one to expand a problem like this without doing the box method.